we are discussing the question of area moment of inertia. Question is given to us. This is a question in which we have been asked to determine movement of inertia about AB axis first. Then we have to determine movement of inertia about CA, ICA. So let us try to understand how to solve this question. It's a very simple question. Normally one of the important category question. So how to do it? So there are two figures. One is the rectangle and one is the semicircle. So movement of inertia for the rectangle is about the centroidal axis. It is 1 by 12 B h cube. If B is the base, h is the height, then it is going to be 1 by 12 BH cube. About the edge, it is going to be 1 by 3 BH cube. So this is the formula we must know before we start this. For the semicircle, the moment of inertia is area moment of inertia we are talking. It is going to be 1 by 8 pi r to the power 4 about this axis. About the centroidal axis, axis is going to be here, which is at a distance of 4 r by 3 pi from the center. This is the centroid. About the centroidal axis, movement of inertia is 0.11 r to the power 4. And about this axis, this is again going to be 1 by 8 pi r to the power 4. So we are supposed to remind or remember these three formulas to attempt this. Now let us try to do how to solve this question. So they have asked us movement of inertia about AB. So IAB, that is movement of inertia about this axis, is equal to IAB for the rectangle. Rectangle is, let us treat as 1, minus movement of inertia about the centroidal axis of this. So that is IAB for the rectangle minus IAB for the semicircle. IAB1 minus IAB2. 1 is standing for rectangle and 2 is standing for semicircle. Now IAB is nothing but this is the rectangle and we are taking movement of inertia about one of the edge. So this is going to be 1 by 3 B h cube. This is about the side, it is not about the centroidal. So 1 by 3 BH cube, we are knowing the formula, we can use it directly. Then movement of inertia about this we know, it is 0.11 r to the power 4. We have to shift it from here to here. So the distance from here to here is required to implement parallel axis theorem. So that is going to be now minus, we'll implement parallel axis theorem. Parallel axis theorem says movement of inertia about any axis is equal to movement of inertia about centroidal axis plus area times perpendicular distance whole square. So IAB for the semicircle is going to be, it is going to be centroidal axis is here and we have to shift it here from here to here. So that is what we are doing. It is going to be 0.11 r means 20 to the power 4 plus area of the semicircle, that is pi r square by 2, half of the circle. Then this distance is going to be, because here to here it is 40, it is going to be 40 minus this distance. This is 4r by 3 pi. So this is 40 minus 4 r by 3 pi. So this is the perpendicular distance between two parallel axes. So moment of inertia about any axis is moment of inertia about centroidal axis plus area times perpendicular distance is this. You can keep it, calculate it, 40 minus 4 r by 3 pi whole square. We'll calculate the complete value and this will give us moment of inertia about AB. So moment of inertia about this is moment of inertia for the rectangle plus moment of inertia for the semicircle. Now let us calculate the second part of the question, that is ICA, moment of inertia about the axis which is parallel to y axis. How to do it? You can write ICA. Now for the rectangle, about this we know 1 by 3 BH cube formula. So again 1 by 3 instead of B we'll have 40, CA is 40, B H cube 60 cube. ICA about this is moment of inertia for the rectangle minus that of going to be for the semicircle. For the semicircle, moment of inertia about this is 1 by 8 pi r to the power 4. We have to shift it to this. So this is for the rectangle minus for the semicircle. For the semicircle, it is going to be 1 by 8 pi r to the power 4 plus area 1 by 2 pi r square into perpendicular distance. Now perpendicular distance is from here to here because centroidal axis of this semicircle is here and we are supposed to shift it to here. The moment of inertia, the perpendicular distance is going to be half of 60, that is 30. So this is, we can calculate moment of inertia about this axis. So we have to be careful whenever parallel axis is to be implemented, be careful if there is a distance between the axes, then moment of inertia is required to be shifted like this. If it is the centroidal axis, we need not require to implement parallel axis theorem. Thank you.